Well, looky here. You're about to figure out what lies under the surface of each planet in the solar system. Get into your spaceship equipped with the largest drill you can only imagine, and off you go. You start with Mercury. It's the closest planet to the Sun. At first sight, the place looks similar to our good old Moon. But after landing, you understand it's an illusion. All around your spaceship, there are craters left by meteorites. The planet's surface is littered with huge steep hills. Some of them are 2 miles high and stretch for hundreds of miles. You start drilling and immediately understand it's going to be tough. Mercury is the second densest planet in the solar system, topped only by Earth. The planet's outer shell is 250 miles of solid crust and rocky mantle. After getting through it, you see Mercury's metallic core. It takes up almost 85% of the planet's volume and contains more iron than any other planet we know about. You don't need to drill anymore, the outer core is liquid. But once you reach the solid inner core, you have to switch that drill on again. The next planet you're going to explore is Venus. It's the hottest planet in the solar system. The average temperatures there are high enough to melt lead. The pressure on the planet is 90 times greater than that on Earth. Your spacecraft is traveling through thick clouds of sulfuric acid. Venus's surface is reddish-brown and extremely dry. You land in the middle of a flat, smooth plain. Plains like this cover 2/3 of the planet's surface. Well, you get down to work. The drill starts moving through the crust. It consists mostly of basalt and is almost 12 miles wide. The next layer is a molten rocky mantle. After some time, you get the feeling it'll never end. No wonder, it's 1,200 miles thick. Finally, you arrive at the planet's metallic iron core. It's huge, twice wider than the mantle. See that blue sphere slightly to the left? It's Earth! How about you skip it for the moment and get back to it later? Right now, Mars sounds so much more exciting. Whew! The place is freezing cold. The temperature is minus 80 degrees Fahrenheit. The planet looks reddish, and as soon as you make your first step on its surface, it becomes clear why. The ground's covered with rusty-colored dust. Its fine particles are also floating in the air around you. In most places, that dust layer is 7 feet thick. You start drilling through the planet's thin crust. It's made up of volcanic basalt rock. Pretty soon, you reach the mantle. It's composed of oxygen, silicates, and other minerals, something like a soft, rocky toothpaste. The red planet's mantle is much thinner than Earth's. It's 1,100 miles thick at most. You feel that the drill begins to move a bit differently. Must be the core. It's made mostly of iron, nickel, and sulfur and is between 900 and 1,200 miles across. And unlike Earth's core, it doesn't move. Time to visit the largest planet of the solar system, Jupiter. Almost 1,300 Earths could fit into this huge thing. It's also alarmingly hot, about 43,000 degrees at the core. But you can't land on Jupiter because it doesn't have any solid surface. The planet is a gas giant, the keyword here being gas. Your drill is also of no use, at least at first. While descending, you watch thick brown, yellow, red, and white clouds passing by. Thanks to them, the planet looks colorful and beautifully striped. You keep going deeper toward the center of the planet. Its atmosphere is made up of hydrogen and helium gas. Soon, you see the hydrogen become liquid under immense atmospheric pressure. And closer to the core, this liquid turns into a mixture of metallic hydrogen and helium. You reach something that looks like a core, but even with the help of your equipment, you can't figure out whether it's a molten ball of liquid or a solid rock 14 to 18 times the mass of Earth. Maybe, one day, astronomers will help you answer this question. The next planet turns out to be exceptionally windy, like me. The winds on Saturn travel at more than 1,100 miles per hour at the equator. From above, it looks as if the gas giant has a solid yellowish-brown surface. You get through several different layers of clouds, and suddenly, you realize you can't land your spacecraft here as well. Saturn is the least dense planet in the solar system. It has only 1/8 the average Earth's density. If you found a pool of water large enough to fit the ring planet, the gas giant would float. If you kept going down, you'd probably have found Saturn's core. It's likely to be rocky, with hydrogen and helium surrounding it. You're approaching the ice giant Uranus, which means there's going to be some surface to land on. Or not. The planet isn't solid. You fly through the upper atmosphere and sink into the liquid icy center. The ice, which makes up 80% of the planet's mass, is actually a hot, dense fluid. It consists of water, ammonia ice, and methane. This part of the planet is sometimes called a water-ammonia ocean. This ice surrounds a solid rocky core. That's where you can finally use your drill. The core's small, half the Earth's mass. Compared to other planets, it's also rather cool, a mere 9,000 degrees. You're reaching the farthest point of your journey, Neptune. It's 4 times the size of Earth, but 17 times as heavy. The bluish surface you see when coming closer is a layer of permanent clouds and swirling gas. Below this surface, there's a large mantle, liquid and red hot. The mantle is rich in methane, ammonia, and water, and equals 15 Earth's masses. At last, you have something to drill. The planet's core is solid. It consists mostly of iron and other metals. Keep drilling until you're at a depth of 4,500 miles. Astronomers are almost sure that's where you'll find a diamond layer. That's right, it rains diamond crystals there. Well, time to go back home. People have drilled pretty deep holes here, but they were never deep enough to even get through the crust. After the drills traveled 1/3 of the way, the temperature reached 360 degrees, and the equipment couldn't operate any longer. But your drill is much stronger than that. That's why you easily move through the crust. It takes up only 1% of Earth's volume and is broken into tectonic plates. They let heat escape from the Earth's interior. You reach the mantle. This layer is about 1,800 miles thick and makes nearly 84% of the planet's volume. It consists of silicate rocks rich in iron and magnesium. Well, you don't need to drill anymore. The 1,500-mile thick outer core is liquid. It consists of iron and nickel, but the pressure isn't high enough for it to be solid. You pass through the boundary between the outer and inner core. It's quite a challenge. The temperature there is 10,800 degrees, as hot as on the sun's surface, and the pressure is 3.3 million times the atmospheric pressure at sea level. The inner core is a solid ball made of iron and nickel. Its radius is 760 miles. It makes 20% of the Earth's radius and 80% of the Moon's. Scientists know what's going on under the crust of the planets that are millions and billions of miles away from us. And they don't even need to go there, drill through their surface and peek inside. They combine information about the planet's density, magnetic field, mountain ranges, heat, and seismic activity to make their smart assumptions. For example, Earth's magnetic field shields us and the atmosphere from solar flares and solar winds. Scientists believe that it exists thanks to a hot iron core inside the planet. It rotates and generates invisible protection, like an enormous scorching hot dynamo. And this magnetic field is way stronger than that on Mars. It probably means that something happened to the red planet's core. Maybe it cooled down and kinda switched off. Or maybe there wasn't any magnetic field to begin with. There are loads of active volcanoes on Earth's surface. That's how scientists can conclude there must be a relatively thin crust, and the mantle must be made of liquid magma. But Martian volcanoes aren't active anymore. There could have been a hot liquid mantle under the planet's crust once, but after the volcanoes formed, something went wrong. The interior probably cooled down, or the crust somehow became thicker. Whatever it was, it successfully stopped magma from getting to the surface. And then there's also seismic activity. If many Earth or Mars or Venus quakes happen on the planet, there's a lot going on under the surface. If we talk about Earth, it's the movements of tectonic plates. Most earthquakes happen along their edges. If there's little seismic activity on the planet, it might have no plate tectonics. Then its interior is calm. Researchers also pay attention to how long it takes a seismic wave to go through a planet or how it echoes inside. It can help to get more information about the density of the crust, what the mantle's made of, and so on. But scientists have to be extremely careful with the causes of these earthquakes. Sometimes they can occur after meteorites hit the planet, and it has no connection with the processes going on under the surface. Of course, these last two methods will only work with rock planets, mainly because gas giants have neither volcanoes nor seismic activity. Boy, all this talk about thin crust and thick crust is making me hungry. Hey, you up for some pizza?
The sun's heat is beneath our feet. Scientists have figured out that Earth's core is actually as hot as the surface of the sun, around 10,800 degrees Fahrenheit. One of the reasons it's so incredibly hot down there is because Earth is still shedding heat from when it was created billions of years ago. Also, when an object as big as Mars slammed into the young Earth, it not only created the moon, according to one theory, but melted the surface of the planet. A lot of that extra heat is probably still stored inside the core. But there's no need to worry. The planet's core is harder for us to access than it is to probe the surface of Pluto. In fact, chances are we may never develop technology that could physically reach the core. There's no air on the moon. But then, how can it be rusting? Scientists have discovered the presence of hematite on the moon, and it's a kind of rust. A special NASA research instrument examined the light reflected off the moon's surface. It turned out that the composition of the satellite's poles was very different from the rest of it. The moon's surface is dotted with iron-rich rocks, but without oxygen and liquid water, rust can't appear. Solar winds add to the mystery. They bombard the moon with hydrogen, and hydrogen makes it much more difficult for hematite to form. Even though the moon doesn't have an atmosphere, it still has some trace amounts of oxygen. Its source is our planet's upper atmosphere. Earth also protects the moon from almost 100% of solar winds, although not all the time. And even though our natural satellite is bone dry, there might be water ice in the shadowed craters on its far side. A day on Uranus lasts 17 hours, 14 minutes, and 24 seconds. But get this, the planet has a tilt of around 98 degrees, and that makes a season on the gas giant last 21 Earth years. Mars has two moons, Phobos and Deimos. In the next 30 to 50 million years, Mars's gravitational forces will tear Phobos apart, and it will likely result in the formation of a ring around the planet. The Earth is the densest in the solar system. At the Earth's center, there's a core that takes up 15% of the planet's volume. It consists of two parts, the outer and the inner core. The inner core is a solid ball made of iron and nickel. Its radius is 760 miles, which makes 20% of the entire Earth's radius and 80% of the Moon's radius. The 1,500-mile thick outer core is liquid. It also consists of iron and nickel, but it's not under enough pressure to be solid. Mars houses the biggest volcano in the solar system. While everything seems to be calm on Mars nowadays, in the past, some sort of force caused enormous volcanoes to form and erupt. One of these volcanoes is Olympus Mons. It's 16 miles tall, which is the height of 3 Mount Everests, and 374 miles across, making it about the size of Arizona. The volcano grew to such a gargantuan size because of the weak gravity on Mars and the lack of tectonic plate movement. Gravity is not the same everywhere. The rocks, metals, and other minerals and substances that make up the planet are packed into the ground more tightly in certain places than in others. This has surprising consequences. Gravity varies slightly depending on where you are. You weigh 0.5% less standing at the equator than you do at the poles. In most cases, that's a difference of less than 1 pound. How high up you are also has an effect. So if you were at the top of Mount Everest, you'd also weigh slightly less. Just don't look down. Earth's toughest living thing is so small you can't see it. Water bears, also known as moss piglets, are cute little creatures with 8 legs and squashed up heads that are less than 1/100 of an inch in length. Despite their microscopic stature, they can basically survive anywhere. They prefer bits of wet moss or the bottom of a lake, but they won't complain if you put them somewhere really uncomfortable. They can endure extreme cold and incredible heat, and survive both huge pressure and high radiation. Some of the little bears once even managed to survive unprotected in outer space for 10 days without a problem. That is tough. They handle all these things by rolling up into a ball and hibernating, which reduces their need for oxygen and food. The moon's gravity is about 17% of that on Earth. If you weighed 200 pounds on our home planet, on the moon, your weight would decrease to a mere 34 pounds. You would also be able to carry stuff 6 times heavier than what you can carry on Earth. It would also be easier to walk on the moon's surface, but it would be more dangerous too. Your feet, inside a heavy spacesuit, would sink into the lunar soil up to 6 inches deep. But let's imagine you decided to skip the tedious process of walking by leaping through the air. Then you'd likely lose control of your jumps in no time. Plus, the moon's surface is littered with deep craters. It would be a tough feat to avoid all of them. You can see solar eclipses because even though the moon is 400 times smaller than the sun, it's also 400 times closer to Earth. So it's perfectly capable of obscuring the star. But in 50 million years, I won't be around then. The moon won't be able to block the sun completely because of the satellite's changing orbit. A full NASA spacesuit costs an unbelievable $12 million. Yeah, I can believe that. 70% of this hefty sum is for the control module and backpack. At the very center of Uranus, there's a rocky core, small, just half the Earth's mass. Compared to other planets, Uranus's core is rather cool, 9,000 degrees Fahrenheit. An ice mantle surrounds the solid core, and that's the largest portion of the planet, about 80%. It's also not the ice you might be thinking about. It's a hot, dense fluid made up of water, ammonia, ice, and methane, sometimes referred to as a water-ammonia ocean. Uranus's atmosphere is mostly hydrogen and helium, but it has its blue-green color because of methane gas that absorbs the red light. The ocean on Jupiter is larger than any other in the solar system. But unlike Earth's oceans, it's made not of water, but of metallic hydrogen. The ocean's depth is a mind-blowing 25,000 miles. That's almost the same as the distance around Earth. Venus is a champ when it comes to volcanoes. The planet has about 1,600 major ones, but none of them is known to erupt. There's a supermassive black hole 250 million light-years away from us. It hums the deepest sound ever detected from any object in the universe. It's 57 octaves lower than the middle C on your piano. That's 1 quadrillion times deeper than what we can hear. Mercury is a few billion years old. In 2016, scientists discovered some abnormalities on the planet's surface, showing that it's getting smaller. After more research, they found out that Mercury hadn't finished cooling down yet. There are planets that aren't bound to any star orbit and aimlessly wander through outer space. Among the most spectacular-looking space objects are pulsars. Pulsars are a type of neutron star. They shoot out some of their material almost at the speed of light. Regular pulsars spin at a reasonable speed, between 1/10 to 60 times per second. But millisecond pulsars can spin at an impressive 700 times a second, which is way too fast for the human eye to even process. As they spin, they emit a beam of radiation from their axis that looks like the light from a lighthouse. Astronomers can notice pulsars when they face Earth, since it looks like a light being shined on our planet. When the light shines elsewhere, the pulsar can't be seen. Our sun is insanely massive. Want some proof? 99.86% of all the mass in the solar system is the mass of the sun. In particular, the hydrogen and helium it's made of. The remaining 0.14% is mostly the mass of the solar system's 8 planets. Saturn's rings are very thin compared to its size. If you had a scale model of the planet that was 3 feet wide, the rings would be 10,000 times thinner than a razor blade. Even though Venus is the hottest planet in our solar system, it still has snow. But not what you'd expect. It snows metals and rains acid. Not a great vacation spot. Among all the planets of the solar system, our Earth is unique, since it's the only one that has developed life. But what if we got a competitor? What if a second Earth appeared out of nowhere? Then there would be 2 different scenarios. The first is the destruction of both planets. The second has an unexpected but pretty logical ending. But let's start with the catastrophic scenario. The second Earth with the same conditions could only exist if it received absolutely the same amount of sunlight as our planet. The orbit that our Earth follows is perfect for getting the necessary amount of solar heat. If we were a little further away, the entire surface of our planet would resemble Antarctica. And if Earth were a little closer to the sun, we'd all live in a huge desert, inhabited by very few living beings. So, for the second Earth to be identical to ours, it would need to follow the orbit of our planet. 2 massive objects can exist close to each other. The union of Earth and the Moon is a great example. But if the second object was as heavy and huge as our planet, there wouldn't be enough space for both of them. The gravity of 2 Earths would be a huge problem. The 2 worlds would collide because they would be pulled toward each other. This process would last for hundreds of millions of years. And in the end, the 2 planets would transform into one giant world. And their remnants would be flying around the newly formed planet, resembling the rings around Saturn. Or one of the planets would push the other out of its orbit. In this case, one of the Earths would hurtle toward the sun and burn like a match in its atmosphere. It's also important to remember that Earth is moving at a speed of 67,000 miles per hour at all times. This is more than 80 times faster than the speed of sound. And now, imagine 2 huge planets that are flying toward each other at such a speed. Even a microscopic organism living in the mouth of a volcano wouldn't stand a chance to survive the collision of 2 Earths. Even the Moon would be torn to pieces by the blast wave. But let's imagine that Earth's twin is following another orbit, somewhere between Mars and Earth. Even in this situation, people's lives would change forever. By the way, the theory that Earth might have a twin appeared long ago. Scientists of the past believed that the second planet could be hiding on the opposite side of the Sun. Thanks to modern technologies in astronomy, we know this theory isn't true. Otherwise, our telescopes and other equipment would have already caught some signals from this planet. Scientists study space objects thousands of light years away from us, so they would definitely notice another world in the neighborhood. But anyway, let's imagine that the second Earth does exist, and we've discovered it recently. The entire field of astronomy and astrophysics will immediately receive hundreds of billions of dollars in funding. The study of Earth's twin will become a priority goal for people. Experts will put forward hundreds of hypotheses about what the second Earth looks like and what's happening there. The planet is almost at the same distance from the Sun as we are. This means the weather must be the same there. Soon, scientists find out that Earth's doppelganger has liquid water and continents, but they aren't like ours. Their shapes and location are different. Most likely, life exists there too. But what is its origin? There's a hypothesis that life on our planet appeared thanks to amino acids brought here by a meteorite. It's highly improbable that the same thing happened to another world. Life most likely emerged there in a completely different way. Perhaps the fish didn't get out of the water on that planet, and the first intelligent creatures appeared in the ocean. These could be amphibians with scales and fins, or octopus-like monsters with huge tentacles. Fish on the second Earth could have come out of the water and grown limbs. But what if they didn't like walking on the ground? Then, this world might be inhabited by intelligent bird people. Or, life could have originated deep in the soil. Then evolution would create humanoid moles or highly developed worms. To find out for sure, scientists send a rover there. A similar mission to Mars was a success, so there shouldn't be any problems with this one. People on Earth are waiting. What will the rover find on the other side? It will take several years for the ship to get there. Strangely, 2 days after the launch, it returns. But wait, this is not our space probe. All this time, the inhabitants of the second Earth have been watching our planet too. At one point, they also sent a probe. It's made of the same materials as ours. It has a camera and a recording device. But people are worried because the rover looks similar to a mechanical spider. Can it be that giant tarantulas live in that world? Scientists understand that we need to communicate. We send our guests a radio signal with some information about our civilization. They catch this message and send their own. It contains strange symbols that resemble scratches. Linguists all over the world are trying to decipher it. Meanwhile, astronomers send the guests a recording of human speech. A few days later, our satellites catch a message from our space neighbors with their voices. Scientists are about to play the recording. The whole world is listening with bated breath, and it's a growl. A terrible and absolutely incomprehensible growl. It has pauses and an unusual rhythm, but it's nothing resembling human speech. The whole planet is panicking. All countries are preparing for an invasion. The most important thing now is to build shields to protect the planet. No one can decrypt the message. It's possible that our neighbors can't understand us either. People make a last attempt to establish some contact. We send a video to explain to our guests with the help of gestures and signs that we only want peace and collaboration. The answer doesn't take long to wait. Our satellite receives their video file. Scientists play back the recording, and it's shocking! We see dinosaurs in robotic suits! Life on the second Earth has been developing in the same way as on our planet. But the infamous colossal meteorite didn't fall there. Over millions of years of evolution, dinosaurs have become sentient. In the video, they're growling and pointing with their claws at the picture of our Earth. Then they start growling even more loudly and... is it laughter? The recording ends. People consider this the announcement of the invasion. Several years have passed. During this time, scientists have exchanged messages with dinosaurs several times, and it seems we're beginning to understand them. It turns out that the reptiles also want peace. They say that their planet was once inhabited by humanoids similar to humans, but a massive flood wiped them away. Dinosaurs managed to survive and evolve into intelligent beings. It will take many years before people set foot on their planet, and when this happens, humanity will feel relieved, realizing that we're not alone. But what if there was no intelligent life on the second Earth? People would also be happy. We would know that we'd always have another home. Perhaps we'd start exploring Earth's twin right away, or begin mining its resources to replenish ours. In any case, our lives wouldn't change immediately, because that land would be too far away from our planet. Dozens of generations would pass before people begin settling on the second Earth. Our homeland planet would be losing more and more resources, so everyone would want to move to a new world. In the beginning, only the richest would be able to do it, but with time, space travel would become cheaper. People would probably invest a lot of money to build a paradise on the second Earth. If this happened, we'd be visiting this world during our vacation to breathe fresh air and enjoy nature. In any case, the human population would grow. This means that sooner or later, the second Earth would become as loaded as the first one, and then people would start searching for a new home among the stars. By the way, if any life exists on a planet similar to ours, it's likely to look like octopuses. There's even a theory that octopuses came to Earth from some other world. Any animal has several evolutionary stages of development. For example, elephants and mammoths descended from one common ancestor 5 to 6 million years ago. Looking even further, almost all mammals evolved from one ancestor they shared with reptiles. Each species has been changing over millions of years. But not octopuses. They suddenly appeared on a family tree. From the point of view of evolution, squids would have to evolve into octopuses millions of years from now. But look, they're already here. Besides, octopuses are incredibly smart. Their genetic code is much more diverse than the human one. They may be visitors from another planet that is similar to ours. But of course, this is only a hypothesis.